Okay, here's lesson 4. Let's go ahead and do the warm-up. You guys go ahead and pause me and work it out and then put me on resume to see if you got it correct. It says the graph of the equation. It's kind of hard to see up here, but it really says y is equal to the absolute value of x is shown in the diagram below. So this right here is the equation of y is equal to the absolute value of x, which is a picture of the shape of a V. It says which diagram could represent a graph of the equation y is equal to, they threw a in there, times the variable, or times the absolute value of x. They're telling us, though, that a has to be greater than -1 and less than 0. So think about a number that's greater than -1 and less than 0. Let's make it somewhat easy and put -0.5 times the absolute value of x. Because your leading coefficient is a negative, that means that your V is going to open down. So this guy is out and this guy is out. The next thing you're going to do is possibly one of the methods you could do is build a table and put in some numbers. If you put in, say, 0 into this, you'd get the absolute value of 0 is 0, and 0 times that would be 0. So 0, 0, which is here, and this one's getting cut off, but it's down here. Let's try a negative number. If you put in, say, -2, the absolute value of a -2 is a +2, and +2 times -1/2 is -1. So 2 -1, or excuse me, -2, -1, or -2, -1. It looks like it's hitting more on this one than anything. Let's go ahead and try 2. Absolute value of 2 is 2, and half of 2 is -1. So 2, -1. It looks like it's hitting. It just doesn't. My eyes aren't that great. Doesn't look like it's hitting that well, but it's definitely not this one. So choice 3 is the answer. Alright, let's look at 8.4, which is multiplying special cases. The square of a binomial. These are just showing you special situations. If you have a plus b squared, which really means a plus b times a plus b, and if you FOIL that out, you're going to end up with a squared plus 2ab plus b squared. If your original binomial is subtraction, notice it's the same thing, except for now this comes out to a minus. But really, sometimes it's just easier for kids to think that x plus 4 squared just means x plus 4 times x plus 4. So you have to FOIL it. Okay? Remember, you cannot use the power rule on this because power rule can only be used on monomials, and this is a binomial. So you cannot use the power rule on this one. Let's look at these two examples. If I have x plus 8 squared, this is a binomial, so I'm not allowed to use the power rule on this. I actually have to write it out and then go ahead and use distributive property, or we could just use it as FOIL. Remember, FOIL stands for first, outer, inners, last. X times x is x squared. Outers is x times 8, which is 8x. Inners is 8x. And last is 8 times 8, which is 64. Your outers and inners typically are like terms, so go ahead and combine those. 8x plus 8x is 16x plus 64. Alright, try number 2 by yourself. Put me on pause, go ahead and try it, and then hit resume. Okay, you should have written these out. Power rule is not allowed to be applied on this one either because it's a binomial. So we have first, which is 2m times 2m, which is 4m squared. Outers, which is 2m times -3, is -6m. Inners, -3 times 2m is -6m. And last is -3 times -3, which is +9. Again, we have like terms here, -6m and -6m. Combining those like terms, we end up with -12m plus 9. These type of questions that you're looking at right now are on the state exam a lot, so be aware of this one. Find the area of the walkway. This is kind of a bird's eye view of a dining room. It's got 2 tables with 4 chairs around each, and then they're giving us the dimensions of it. The thing that you have to be careful on this one is that they gave us the dimensions of the dining room, which is from here to here, so it's x by x, and then they tell you the 3 feet is actually the width of the walkway. So be careful with that one, because some kids think that's actually the dimensions of the square, but it's not. The dimensions of the dining room and the walkway included are x plus 6 by x plus 6. The x plus 6, if you think about it, it makes sense because from here to here is x, and then you've got a 3-foot walkway and a 3-foot walkway, so altogether you have 3 plus x plus 3 would be x plus 6. That's where that's coming from. They want me to find the area of the walkway. So really what you're going to do is you're going to find the area of the whole bigger square. Put a little diagram, and the squares are side by side. So it's x plus 6 times x plus 6. Let's go ahead and FOIL that out first. Outers, inners, and last. If you combine your like terms, you get x squared plus 12x plus 36. This represents the area of the big square, which is the dining room plus the walkway. The area of the smaller square is equal to just the dining room, so not the walkway. And the dining room is x by x long. So that's going to be x times x, which comes out to x squared. So if they just want you to find the walkway, that means you have to take the whole picture and subtract off the dining room. So if you cut this out, you'll be left with just the border, which is the walkway. So take the bigger picture, which is your x squared, plus 12x plus 36. That's this trinomial that you just figured out. And you're going to subtract off the dining room dimensions area, which is the x squared. That's this guy right here. When you subtract those, the like terms are going to, these like terms are going to end up canceling, and you're left with 12x plus 36 square feet. Let's cut that off. Alright, difference of perfect squares. This one you're going to hear a lot through high school and college math. It's a good observation. If you notice that you have the same binomial multiplied by itself, the only difference is they're one of each sign. What happens is, let's look at this example right here. When you take x plus 2 and you multiply it by the same thing except for change its sign, when we FOIL this, watch what happens to it. First would be x squared, outers is 2x, or negative 2x, inners is positive 2x, and last is negative 4. When you combine your like terms, this one and this one, because you had opposite signs up here, operations, the negative 2x and the positive 2x actually cancel with each other, and you're left with x squared minus 4, which means that your answer, if you notice, it's a binomial. Usually they're trinomials when you do FOIL. This is a binomial because of what the original problem started at, and it's x squared minus 4. They call it difference of perfect squares. Why? Because we're difference, which is subtract. This is a perfect square, and this is a perfect square. So that's where the name is coming from. All right, let's try a couple on your own. Go ahead and try these when you're done. Make sure you put me on pause, and then when you're done, we'll work it out together. All right, in the first one, it looks like these are differences, can be difference of perfect squares, but they're not because they're both the same sign. So your answer is going to come out as a trinomial. When you FOIL it, you get first, outers, inners, and last. Combining your like terms, you get c squared plus 6c plus 9. And the second one, be careful because you can't use the power rule, and that's what they're going to try to trip us on. You have to, multiply this out as FOIL because it's a binomial being squared. So first, outers, inners, and last. Combining my like terms, I get g squared minus 8g plus 16. If you look at this, notice that they're the same binomials, but the signs are different. So what should happen when we multiply this out? 2r times 2r is 4r squared. Outers would be 6r. Inners would be negative 6r. And last would be negative 9. Notice that the outers and inners are going to cancel. Hopefully that's what you recognize to begin with. And you get 4r squared minus 9. That's a binomial. This is difference of perfect squares. In number 4, it says a square has a side length. Don't forget, a square means all sides are equal. What is the area of the square? Well, the area of any square is side by side, so it's really 2x plus 3 times 2x plus 3. Using FOIL, we get 4x squared. Outers give me 6x. Inners and last. So my area, I'll put it over here, is equal to 4x squared. Combining my outers and my inners, 12x plus 9 inches squared, square inches. Okay, so that takes care of 8.4.